All right, so we're live. Welcome, everybody. This is the bi-weekly ONOS TST meeting. It's a public and recorded meeting, so keep that in mind. Today, we're going to provide another one in a series of updates on the µONOS project progress. It's probably going to be provided by team members such as Adib, Sean, and Andrea. Jordan, you also had some stuff too, I believe, right? So let's start with the debugging.
All right.
Is that right?
Yes, okay.
I'll pass the control to you, Adib. My presenter.
All right. Can you see my screen, right?
Yes.
All right. Okay. So I want to talk about debugging of the ONOS subsystems. For example, ONOS config in ONIT cluster. The idea is here is that we would like to debug an ONOS subsystem which is running in a Kubernetes cluster. So it's like a remote debugging. It means that from our client, from our IDE, we would like to connect to a remote debugger which is running in a pod, in a container, and debug the program as it's running in the Kubernetes cluster. So we have an example of that in the documents. If you go to the testing section, so there is a section debugging, it points to this page. And we have an example of the debugging of ONOS config subsystem in ONIT cluster using Golang IDE and also using the Delve client. So Delve, we use Delve as a debugger, which is a popular debugger for Go programming language. So the recommended option for debugging is use the Golang IDE because it gives you more flexibility when compared with the DLV client. DLV client is just a simple client for testing purposes, so it doesn't give you so much flexibility. It's very similar to the GDB in terms of the syntax and the usage. So in this example, we assume that you already started a current cluster and also you deployed the ONIT cluster and ONOS config pod, Atomics, or Raft, all of them are running and ready. So, and we would like to configure the Golang IDE to connect to the remote debugger. So the ONOS config pod, the container which runs the ONOS config, started a Delve debugger server which listening on port 40,000. So the first step to start the debugging, we need to, if we look at here, we need to configure the debugger to listen to connect to the port which the debugger is listening on. So in this case, the 40,000. So there is an option in the run debug configuration of the Golang IDE that you can set the local host and then specify the port number. The next step for the debugging, we need to, using the ONIT command line interface, we need to start a debugging session. So for a specific pod, for example, here in this case for ONOS config pod. So, and we use the port forwarding, which forwards the local port to the remote port. And then after that, in this step, as you can see, we have started debugging session from here, and the debugger will be connected to the client will be connected to the remote debugger. We already enabled the logging in the debugger in the server side, so it means that whenever you send the command to the debugger, so a log message will be printed on the on that pod. It means you have access to these log messages using ONIT get logs command. So that you can see the log messages for a specific pod. In this case, it's ONOS config. So whatever command you send from the client, from the IDE, you should be able to see a message. Here it says that the debugger is connected and then it's continuing. It means that the program is running now. So the next step, After the debugger is connected, you should be able to see these two messages. So you can see them using the onIt get logs and the name of the config. And the next step is suppose that we would like to add a simulator to the ONIT cluster, and we would like at the same time debug as the synchronizer code, right? So in this case, we set breakpoints, and when we set the breakpoints in the IDE, we see some messages again in the log, which shows that we already set two breakpoints. For example, a breakpoint at line 85, and we also have a breakpoint at line 75, right? So when we add a simulator, the simulator will be added, and the debugger will be stopped at this breakpoint. So we will be able to see, we will be able to go through the variables, check the values, as you can see here. So in the debugger dashboard, for example, we added a simulator. The name of the simulator is Sim1, which is listening on port 10161, right? All of this information is available in this example. So other than that, we also be able to set trace points in the Golang ID, which is an interesting feature. It means that suppose that you don't want to pause the program, but you would like to trace the execution by printing a message to see that a line of the code is executed or not. You want to print a variable, so without pausing the program. We have this feature also using the trace points, as you can see here. So we right-click on the breakpoint and remove the suspend from that breakpoint. So whenever that line hits, so the program won't be paused, it just keep running, but a message will be printed on the console. So for example, in this example, when we add a simulator, we have a trace point instead of a breakpoint. So as you can see, there is no pause in the program. The program is completely executed, but we have messages printed on the console because we have trace. So this is an example using Golang ID. We have also an example using the simple Delft client. So again, we would recommend to use the Golang ID debugger, which is more flexible when compared with the Delft client. Any questions, any comments about the debugging of the ONOS config? So this is not limited to ONOS config when we deploy other subsystems. So we can do the same thing for other subsystems. Any questions? No. Okay.
Yeah, if not, this is really great. This is really useful. And just to be sure for everybody, the Docker container or the process has to be run with special options, as you alluded to, right? It still has to be a debug image.
Yes, okay. Exactly. So in ONIT, we run an ONOS config debug image, which runs a DLV server running.
Right. Yeah, so that's the ONOS config image. There's a tag for the image called debug. I just pushed it to Docker Hub also the other day, so it's in Docker Hub.
Yes, perfect. We have it.
And this is going to be extremely useful.
And well done on the documentation and the videos as well, Adib. That's very handy.
Yep.
Thank you. Yeah. So I was thinking that instead of writing all of this stuff, it's better to visualize it.
Absolutely. Absolutely.
Much better.
Yeah.
Yeah.
Thanks.
Perfect. This is a very nice show. Okay. So next enhancement is the operational state cache. I assume you're going to cover that, Sean?
Oh, that's Andrea's going to cover this one, I think.
Or is it Andrea? Okay.
Yeah, that's me. Okay, let me share my screen so you guys can see it.
Yeah.
Can you see it?
Yep.
Okay, so here on the right, starting an ONOS config instance locally just for testing. The two things we did was we enabled both operational state cache get and a get on the wildcard paths. So when I say operational state cache, really what I mean is that now ONOS config is capable of subscribing to read-only paths of the devices based on the device model that the device has, and that populates a cache out of these paths that is updated every time there is a new notification. And we're now capable of doing a get against this operational state cache that obviously cannot be modified. And so if we will try modification of this cache, it will fail. But if we just do get, it will tell us the value of that element that is a read-only element. In this case, in particular, I want to focus everybody's attention on the fact that we are asking localhost 1 for a particular address under the state path of the controller's OpenFlow controller connection auxiliary ID 0. So for that particular connection, which is the main connection, so for the main controller, the particular connection, which is auxiliary value 0, we're asking for the address. This is not something that we can set. If this would have been config, we could have set that. But instead, since this is state, this is the device telling everybody, this is what I have configured on myself. So if we issue this request against the ONOS config that we had running, you will see that we will get the value of that address. And this again is the state address value. So that's the operational state cache, and this gets updated every time the device changes something in terms of state. Since we subscribe to it, we get a notification, we change it into the operational state cache, and a get does show that change. The other major update we had lately on the capabilities on the northbound of ONOS config, and obviously plumb down to the southbound and the stores, is adding the wildcard paths. So again, I'm going to use the GNMI CLI to show it, but the idea is that we want to see everything which is under a certain path, or everything for a certain key. So for example, in this case, I'm piggybacking on the previous example to follow it up better. We're again asking for the same system OpenFlow controller connections, but we're asking them for any possible controller, any possible connection, and we're asking for everything, both state and configuration, underneath it. So the wildcard is an asterisk, as is specified in the GNMI spec. So if we issue this against the same ONOS config we had running there, we get a JSON value back, which I, for convenience sake, ported to a nicer representation. So this particular JSON we get for, again, you see it's element controller, every type, every controller, because the key is star, every connection, because the auxiliary ID key is star, on localhost 1. So if we take a look at that, we see that we get two controllers. One is named main controllers. Like, there is one controller named main and the other one named the second. Each of those controller has a set of connections. The first one is auxiliary ID 0 and the second one is auxiliary ID 1. And we see here that there is both configuration and state, because we did not specify the state request as we did before. So now we see both. And as before, we were seeing the 192.0.2.10. That is because it was set by ONOS config itself with a configuration. And on the second controller, again, we see two different auxiliary IDs, 1 and 0, two different connections. So with just one path, we get the JSON value back that contains everything, and that is masked with that wildcard asterisk path. Any questions?
This is great. And this will also be clearly possible, not just for get, but also subscribe, right?
Yes, indeed. That is definitely possible also for subscribe.
Yeah, that's awesome.
There is, if you just bring up the path again, Andrea, there is another wildcard supported in there. So say, for instance, like say in this top one, if the word OpenFlow was replaced with star, then it would come back with anything that had a controller connections, etc., like this. And then another possibility is OU to replace.
Yeah, in this case, there's really nothing else that has a controller. Yeah. But we got back the same OpenFlow 1 with substituting the star in here.
And if you wanted to go a step further, you could replace system by star, or alternatively, if you wanted it to match multiple stars in a row, as in like I want any amount of containers, you could go ... instead of asterisks. That's in the GLMI spec as well, and we support that as well.
Oh, that's great. The target itself cannot be the wildcard, correct?
Yeah, if you wildcard the target, you just get a list of target names back. We didn't want every config for every target to come back.
Yeah.
So yeah, you would have to iterate over every target or every known target to enable to get the config.
Yeah, I mean it's a way of protecting the system. We don't want it swamped by huge requests because there could be any number of targets in the system.
Yeah, this is great. Nice.
Okay. Also, before I leave this, I have created two integration tests for both the read-only paths and the wildcard. So if you take a look at the current code base, you will see under the test integration, you will see single state test. This tests the fact that we can go for a very specific read-only path and we get the value back. That's the same address that I used before. And I've also created a wildcard path that tests a few different possibilities with any type of state, both state and config, just state for the address, all the state for that connection, and all the state and configuration for that connection. So this is also being included in the master branch. Any questions?
I don't have any. Anybody else online? If not, this is great. So I think we're done with the first three then, so we can probably move on to the GUI.
I'll give back presentation rights.
We're not using the projector.
Yeah, okay, so I'll share my desktop here. Hopefully you can all see it. Can you see this? I'm presenting a slide.
Correct, we can.
Yeah. Okay. So yeah, I was just going to briefly touch on the slide that I presented the last day, and I've kind of built on that, and I intend to do a demo. So basically, I have a net changes view, I have a config view, very preliminary now at this stage, and I haven't done the configs plural view. But let me see, I was going to share my browser. So this is running off this is running off a machine next to me here. So basically, this is the network changes view, and what I have is I'm showing there's one network change in the system, and I'm going to run another network change in a minute. But this one, I can click on it, and it brings up the details of that network change. So you can see it affects one device, and it's got a link there where I can link to that device. I was just going to just in a terminal window to do another network change. So basically, this is making an adjustment to two devices, both localhost 1 and localhost 2, and hopefully this is going to work for me. Yeah, okay. So this did the set on both of them, and gives me back the name Youthful Corna. No, this isn't dynamically driven yet, and I am going to take care of that. And I'm going to have to get my bookmark here for this. But this is going to show up that Youthful Corna here now, and so basically I can see that there were two devices involved in it. Okay, so just going back to this one, then if I click on this one, it's going to bring me into the config view. Now this is a very early stage, but basically what it's doing is it's trying to develop a tree of all the containers, and that includes lists and leaves. So the containers are in blue and the leaves are in green, and really this is very early stage. They will all be distributed and arranged like nodes are in the ONOS topology view that everybody's familiar with. But what I have here on the left is a kind of a way of controlling the tab or the layers, right? So each configuration for a device is made up of a layering of the first change, and then on top of it the second change, and then on top of it the third change, and this allows me to control those things. Now, a configuration that I'm like editing or viewing here can either be just a configuration, or it can be a configuration attached to a live device. And if it is attached to a live device, then the state will show up, and I will see the state as well. Like here, for instance, I'm not actually pulling from Andrea's operational state cache. I just haven't got that far. But basically, I'm just displaying the name of the state layer. So basically, I've got several layers in here. So when it comes to editing, then I have this plus symbol, and again, like this is very preliminary, but what it does is it allows you to make a change, and it comes up with this dialog. Do you want to make a new network change? And it's going to call it pending. So basically, I click OK. And what this is going to do is add on another layer temporarily called pending. No, the icon is showing it's sorry, the icon is not updating properly, but you can see the I'm going to turn off stage. You can see the label for the pending here, and so basically this pending layer is going to hang around now until I actually decide to make the change. But a network change is something that happens across multiple devices. So if I go back to my network changes view, I can see my pending network change here. It hasn't been named, it hasn't been sent down to ONOS config. And when I click on it, it's going to show me that it already contains device 1, but it allows me to add other devices as well. So now I can go in here, and this has a pending change as well. So I can like click on that pending layer. I can pick on either say all the config or whatever I want, and now click on the plus or edit or whatever it would be, and basically that would start adding to my my network change. So what I'd end up with is I end up with a set of devices on this network change that like are sitting around. It has device 1 and device 2, and at some, like, I haven't added it yet, but basically there would be a commit button here, there would be a delete button here. I could back certain devices out of my pending change. I could there might be a commit button up here that would allow me to commit it, which would send it down to ONOS config. Like here, if I wanted to discard it, I can just discard that pending change, and now I'm back to my original 2. And then I have a rollback button. Now, rollback isn't implemented yet either, but basically this is something that would send the message down to the ONOS config and try to roll back the network change that was made on device 1 here. If that rollback was not allowed, I get an error message here. But I mean, this is the kind of thing I was doing with this. Let me go back to my slides. So yeah, you can see the plan was network changes with rollback on each one. I decided instead to use the existing ONOS GUI kind of layout, and the config view and the editor as an SVG that can expand and have pan and zoom, and isn't bound by the usual rules of HTML, like we did with the ONOS topology GUI. And I've merged these together, the device and the layers kind of view. Let me see, any questions on that?
This is excellent.
Really cool.
Okay, thanks. I had another slide here on just the deployment. So let me just jump to that one. Yeah, so talked to Jordan a bit about this yesterday, and this is the kind of structure for the GUI. So on the subject of ingresses, so basically when it's deployed on Kubernetes, effectively we will have, the current plan is to have almost 3 levels of proxy, okay? So the top level one is an ingress proxy, and from what we've seen on the web, an ingress proxy into a Kubernetes cluster isn't really meant to serve up static files. So this is, but it's needed for allowing access to the outside world into any of the servers internally. So that ingress proxy basically would probably be Nginx, and it would have just a proxy pass going to the ONOS GUI on, say, port 80 or 443. And then it would have a gRPC pass for each one of the ONOS subsystems. In fact, they could, there might be a variety of ports here, 5150, 5250, so on like this, linking to each one of the submodules or even clusters of the same. And that would be configured in this ingress proxy server. Then beneath it, the ONOS GUI, this also needs Nginx because really ONOS GUI is really about serving up static files. There isn't even a Go module in what I've shown. All of the static files basically are what was compiled by the Angular compiler and put into this location, and some bitmap files and that kind of thing as well. And what that Nginx does is it has a proxy pass down to ONOS config Envoy. Envoy is another proxy server that comes from the company Lyft, and it currently doesn't support serving static files. But what it does do is it allows a mapping between gRPC web and gRPC. Okay, and gRPC web is a HTTP 1.1 protocol that basically supports all the features of gRPC, but puts it in a way where you can access it from JavaScript inside a browser. So gRPC Web is a necessary part of the browser JavaScript environment, and it's Envoy does the translation there from that to actually making gRPC calls. And what I showed you is that in effect all of that working. I'm going through Nginx for its proxy pass down to Envoy for its gRPC web translation, and down to ONOS config to make those gRPC calls. And so then I think there probably would be an Envoy deployment for each one of the ONOS subsystems, because each one of those will offer gRPC services that we want to access from the web as well. So I think the green lines here effectively are the northbound interface for real gRPC, and then the blue basically is the access to support the ONOS GUI. So that was.
So there's going to be an instance of Envoy per ONOS service?
Yes, I think that is probably the best way to go. I mean, I was thinking, could you merge them all into one? Probably not. I don't think it's the Kubernetes way to go. I mean, I think Kubernetes wants things to be microservices and wants things to be, modular, so that if you unloaded ONOS config, you'd unload the Envoy related to it as well, and you'd have a clean break.
And are there going to be multiple instances of Envoy per service for redundancy, HA, that type of thing?
So I think you'd have the ONOS config Envoy is configured through a YAML file, and it can point to a cluster of ONOS configs. So could you have ONOS config Envoy duplicated? Yes, you could as well with a replicated YAML file in there pointing at the same set of ONOS configs. So there's a lot of flexibility around it, how we deploy it. I think ONOS GUI itself, that can be replicated as well, and point to, we'll say, more than one ONOS Envoy for ONOS config. And the ingress proxy can be set up to know about a cluster of ONOS GUIs. So I don't think it's like mayhem or like free for all, but I think the flexibility is there with this kind of a setup to get redundancy in all of those layers.
Yeah. That was just the last question was really: is there a concern about redundancy at the Envoy layer, that we need multiple instances or just a single instance fast fail? I'm just curious if you have any insight into how like Lyft has been implementing it for them and deploying it for them. Yeah,
I haven't had a chance really to examine it at that to that level, but that's part of the plan. I mean, the next kind of step for me is to build a Helm chart for deploying ONOS GUI and its the config Envoy. And I think as I do these Helm charts, I'll delve more into that, deployment.
Okay. And you've set up the ingress proxy in Kubernetes?
No, not yet. No.
Okay, I'd love to hear that.
Yeah, I mean the gRPC is. I mean, Nginx 1.17 has said that it can do full gRPC pass. I've yet to prove it, so I don't know. And the other thing that Jordan pointed out yesterday is that Nginx as a Kubernetes ingress doesn't support a mix of HTTP and HTTPS. So I think there probably are many hurdles to cross there.
All right, thank you.
So I've done it I've done the ingress for gRPC. We haven't done a full setup yet of gRPC plus the GUI traffic and things like that. So
you deployed the ingress controller for gRPC?
Yep. Yeah.
Oh, do you have a write-up of that anywhere? Or?
Yeah, I can send it to you.
I'd appreciate that. Thank you.
So I thought you had that working in Milan, though, right?
Yes.
Yeah. Right.
Yeah, that's something that we've had that working for a while. Yeah.
Yeah, and conversely, though, David, if you have any pointers and tips from your experience with CBA Volta deployments, please don't be shy and let us know where we might be straying.
I will. I just, yeah, the Ingress, I played with the Ingress for a while. I thought, oh, this is just a pain in the neck. And so if someone else has already done the hard lifting and I can just borrow, that's a good thing.
Absolutely. This is
Okay. Any questions on this? I guess that's really all I was going to say on it.
Oh, this is great. This is awesome progress, Sean.
Yeah.
Okay, good.
And it's also good to see the work, all the work you've done on migrating the ONOS Classic UI is showing up here as well.
Yep.
Yeah, I got a fair amount of reuse out of it, and you know, I think things like the pan and zoom and the SVG view, I think that's something I can just lift from it, hopefully. So yeah, hopefully get something decent going for the ONF Connect.
Excellent. Nice.
Okay, I'll stop sharing here.
So moving on it to its own repo next. So who is it gonna be? No, well, no. It should. I'm gonna let you or Jordan.
Yeah.
So who wants the steering here?
Jordan, good. Let Jordan go.
Okay, Jordan. I'm gonna pass the buck to you.
We are in the process. We just wanted to give you an update.
Right.
Okay, 1 second.
You got my invite to present, right?
Yep. I'm trying to. Okay. Yeah. So actually, maybe. Yeah, so up until now, so I mean, in the last few demos, we've talked about this test framework, which is on it, so it runs ONOS config and lots of other components on Kubernetes. So up until now, it's been sort of encapsulated in the ONOS config project. But since we began working on Topo, it's sort of the topology work sort of started creeping into ONOS config, so we wanted to move it into a separate repository, and so we added this ONOS test repository. So there's a pull request open currently to move it all over there, and so this is pretty much the same code that was in ONOS config, but the goal is, so we're going to move it here to ONOS test. At the start, we'll have the integration tests here also, because there are sort of some complexities that I don't want to try to address yet, which is how does this run tests that are potentially in a bunch of different repositories? How does it run config tests and topo tests, and understand where they are, how to find them, how to list them, and how to deploy and run them. I think that's something we'll have to address later. So for now, it's easier to just also house the tests in this repository. But this will allow us to run topology and run config and run test those things. So,
Jordan, I actually kind of like that for integration tests, because that way there's no dependency creep, right? It's all going to be through GNMI. There's really no other way you're going to be able to affect the running components. So I think that's actually a good thing.
yeah, I actually kind of do also because it's, as we add more services, I feel like it's probably going to become kind of blurry what a given test is testing, because it can also, any test can also just reach out to any service that it wants to. That's
Right.
You can see the.
I mean, we already sort of do that, right? Because we have some tests that reach right into the device sim, which is built completely separately. So I think this makes total sense to me.
Yeah. So that's it. That's the work in progress.
So this, I think, will mean, so the only thing I don't like about this, of course, now I'm contradicting myself. We currently have a job set up on Travis such that when we get a check-in to ONOS config, it runs the integration tests.
Yep.
I don't think we can do that with this setup. We may have to run it timed or something.
Yeah.
Because I don't think you can do those webhooks across different repos on the Travis end.
But you should be able to pull them. Well, yeah, then you can't really add tests along with code that you're adding.
Yeah, we'll figure something out. You're right.
Yeah.
I mean, it's always been the balance, right? Balancing the monorepo versus distributed repo type approach is going to have.
Yeah, I'll see if there's any way, like in Jenkins, you can do these sort of polling things. You can say, hey, here's a Git repo, and when there's a change, do this. I don't know if you can do that with Travis, but I'll take a look. We'd have to change that.
Yeah, but you can maybe set up some sort of a notification tree, right?
Yes. Yes, exactly.
Now, this is really useful. Now, related to this thing, but at least related to the concept of pulling things out of a repo into common area, where do you think we stand with the ONOS CLI? Because with ONOS CLI, we also have at least some redundant infrastructure in each of the repos, and also currently the ONOS config kind of squats on the quote ONOS name, ONOS CLI name. Should we abandon this ONOS, the common root name ONOS CLI? Should we have like ONOS, basically a CLI for each of the subsystems and keep them together? Yeah. That would be one way of going with it. Another way would be to completely extract the ONOS client out and then treat the client effectively as kind of the ONOS integration test here.
That's kind of what I was thinking that way. To have a single CLI that has, because you have this notion of like stepped, I don't know what you'd call it, but it's like a subtree in the commands.
Mm-hmm. Yeah.
So you'd say, ONOS topology list devices or something, and have that as a single program. That's kind of what I was thinking.
What I was leaning towards myself, but there's some downsides to it, right? In the sense that once we extract it, then the CLI effectively becomes really just like another client.
It's an app.
It's just exactly. It's just like another client, and so this will kind of.
Why is that a downside?
Well, it's a very good question. I completely agree with you, but I'm just trying to be a devil's advocate here, because we've seen cases like, for example, where you want to make kind of synchronized changes. Let's say if you evolving something, but in theory, if the CLI goes through the official interfaces, those official interfaces ought not to be moving much, right? At least moving in a backwards compatible way. So it really shouldn't have any such effects. But I know that that's a theory, and often the difference between theory and practice is larger in practice than in theory. So,
I think having a single command with subtree commands is perfectly in line with kind of what everything else is doing. Kubernetes,
right?
Vagrant, Cord, you name it, they're all kind of going that direction. So I think it makes perfect sense to follow that pattern.
Yeah,
and that's exactly my kind of intuition. But I just wanted to run it by everybody. And of course, if you decide to do it, we have to then figure out when we do it, right? Do we do it before or after the kind of the push towards the ONF Connect demo?
So Jordan, if we did something like, so we're going to split out ONIT, we're going to split out the CLI. Let's say we do that. Currently, those Docker images are all built inside ONOS config, right?
Yep.
So we'd have to have like a multi-tier. If you wanted to actually run the integration tests or run the CLI, we'd have to have some kind of multi-tiered build to do that.
Yeah. Well, I mean, no, because so this is why we're moving the integration tests into the test repo, because the integration tests are actually what are run when you're running the integration tests. So if they're on it, you just have to build on it. If
Okay.
you make a change to the integration test, you're just adding those integration tests to kind or whatever you're running. And then the other images can be pulled from Docker Hub, but if you're making changes to them locally, then it's just your responsibility to ensure that those changes are accessible in kind if you're running the tests on kind or something like that.
Yep.
Right, but I guess what I'm saying is now, like to take the CLI, the deployment of that, the building of the Docker image, that will follow that code, right? So you have to do, I guess what I'm saying is, once we do this, it'll be common practice for us in development to do builds in multiple repos.
Yes.
Okay.
Yeah.
Yeah, I mean, for instance, yesterday, right? So the admin protocol changed on ONOS config. So I mean, you know, the integration, or sorry, the Travis tests wouldn't catch the fact that the CLI hasn't caught up. You know, so
Right.
I mean, it's only when you do an integration test or a multi-repo build that you'll actually see that the two of those have got out of sync. And it's the same for the GUI. In fact, you know, I've got to recompile my protos for gRPC web to work now that the protos have changed.
Yeah, that's true. I mean, I think that's true. Probably truer now than it should be in the future. Like Thomas said, we're iterating and making changes a lot more, and we're allowing breaking changes currently. But once we get past the release, I mean, the purpose of protobuf is to ensure you can make changes that do not break science.
Right.
Issue now and in the future, hopefully.
Yeah, the other concern I have is like some places in the CLI code, it's reusing some of the packages from, you know, the main ONOS config. You know, so things like, for instance, handling JSON tree or something like this. You know, would that become a problem if ONOS CLI is out in its own repo?
Do you know, Thomas? Is it using any of the ONOS config code right now?
I mean, it might be. Don't recall
Well,
specifically.
no, I know it is.
Oh, you do? Okay. So that, I guess that would mean then we're back to this needing a common, like
Yeah,
shared
so
repo.
we either have a common, or we extract it out, or we leave a little bit of redundancy.
Yeah.
I mean, within the CLI code, right, you can just do, you know, go get of the ONOS config, I guess. Is that how it works?
I think so.
I mean, yeah.
We have imports from the ONOS config.
Yeah.
In the command,
Yeah, okay. So basically, you'll get the master, I guess. So if you're trying to debug something, you might get a different label or something like this. But yeah, it's probably workable, I think.
Yeah. So, well, we have the repo set up for it. So clearly, that was sort of the plan. But I just wanted to, since we were on a subject of extracting things out of into its own realm, I figure we might as well touch on the CLI as well.
So given all this, I think we should probably delay this until after.
Yeah, I think so. I think, well, the thing is, I think the plan was that to do that with ONOS on it as well. But I think this is an example where sticking with that original plan would have been more of a hurdle, and so the guys decided to take it on, which is great. Yeah, but I agree with the CLI. We can wait.
The question is that do we want to have ONOS CLI as a separate part in the Kubernetes, or so if it's supposed to have ingress, I guess by ONF Connect we need to move ONOS CLI to deploy it as a separate part, but I don't know. So otherwise we should run ONOS CLI from the config.
Well,
no, we don't we don't need the CLI to be a pod because the CLI, I mean, if there's an ingress, then you just run the CLI locally through the ingress, and it's just gRPC to config. Or...
CLI should be a program, I think, that you can install locally, and it just has.
Yeah, it's external to the cluster.
Yeah.
Yeah.
Okay.
All right. So I think that's it, right? The ONOS GUID development deployment. Did you cover that, right?
Yeah.
Yeah. So I think that's all.
Okay.
So just maybe just to use the last few minutes just to kind of circle back to the ONF Connect demo. We got the first round of feedback from Guru and from others. We're most likely going to demonstrate also just an example of zero-touch provisioning as part of this. Again, it'll be just an example. It won't be a just to help the attendees of the demo or the viewers of the demo, to help spur their imagination as to how this can be used in a comprehensive way with both configuration and control aspects to be able to add a new switch easily to the network and or remove it if need be. We're still kind of developing the script and the specifics for it, but most likely this will then mean that we will have to have 3 stratum switches for our demonstration instead of the originally planned 2. We'll probably develop the script to some point where we should be able to share some details in 2 weeks as to kind of what we're expecting to show. If there is anybody that sees some exciting areas where they would want to help, I encourage everybody to come join our Slack channel, look at the pull requests, look at the issues in the repos, and don't hesitate to take work on. We welcome any and all help that we can get. So hopefully, we're hoping to widen the team as time goes on. That would be great.
Thomas, one question was about scalability and performance. I remember previously there was a requirement that we would show this running with 30 devices. Is that something that we hope to do for ONF Connect?
No. I think for ONF Connect, the idea is just to show just kind of the base functionality, kind of the principal pieces of ONOS config primarily, right? Which is the ability to be able to do the basics of GNMI through southbound, re-expose them through northbound, to be able to do multi-device transactions, meaning all or nothing. When you apply an operation through the ONOS northbound, to do the all or nothing on a southbound, and then be able to show the kind of the internal state of the system, about the changes as they're layered, as you're working towards the GUI and the commands that show that. So I think that's the primary goal. I think the scale, as you mentioned, I mean, the goal is, I think actually we've upped the goal to be able to support 50 devices. I think, I forget the specifics, but we've upped the goal. But that's not for the demo itself. That's just for down the line.
Okay.
So since it's nearing 10 o'clock, if there are no other questions or comments, I think we can call the meeting done. And the plan is to hold another one in 2 weeks. All right. I guess no other questions, so we can call it a day. Bye-bye, everybody.
Thanks, everybody. Take care. Bye-bye.
Thanks for that.
Bye-bye.